Okay, hello. I thought I would run through one of these problems because I know that there's a learning curve with learning how to use these graphing tools. So we have this piecewise function, and this one's different from types 2 and 1 because we have a quadratic function this time. And in this case, we are cutting the parabola once, and we are going to be keeping the part that has the x values that are less than 1. So we are going to be keeping the left-hand side of the parabola. So what I need to do to graph this is I need to first of all go ahead and pick the parabola tool. And be careful putting extra points on your graph because Alex might not like that. So I'm just going to try to graph the bare minimum here. So I first of all need to figure out where my vertex is. If I use negative b over 2a, my b is 0. Some of you have just memorized that the x value of this parabola will be 0. And if I plug 0 in, 1 plus 0 squared gives me 1, so the vertex is at 0, 1. And so next is asking me to choose how the curve opens. Because I have a 1x squared and that's positive, it goes up, so I click. And I need another point, so I can pick any other x value besides 0. I'll go ahead and plug 1 in. So 1 plus 1 squared is 2, so I have an x value of 1 and a y value of 2. So I now have the parabola y equals 1 plus x squared. And now I need to cut it and throw part of it away. So I will grab the scissors tool, and I'm cutting this at x equals 1. And so I'm going to plug 1 in. I know that there's a less than sign, but I'm still going to go ahead and use 1. And if I plug 1 in, well, we already figured out that's 2. The y value is 2. So I plot the point to edit the graph. And now if I grab the eraser tool, I can erase part of the graph. So I need to erase the part where x is greater than 1. I'm going to go ahead and put my open point. I might need to come back and turn this into a closed point, but I don't want to forget about it. So then I want to graph the second part of it. Y equals 2x plus 3 is a straight line. It has a y-intercept of 3, and it has a slope of 2. I could graph the entire line and then cut it at 1 and throw half of it away. It's much more direct just to use the ray tool. So I will grab the ray. And so my left endpoint is going to be at x equals 1. And if I plug 1 in, I get 2 plus 3, so I get 5. So my point will be the point 1, 5. So in this case, those 2 points do not coincide. I can pick another x value bigger than 2. If I pick 2, 2 times 2 is 4, 4 plus 3 is 7, I get the point 2, 7. I could also use the slope there to find a second point. And I can verify I went up to right 1, and that goes with the slope being 2. And then I need my endpoint, and the equal sign tells me I'm using the solid dot, and so I will place that there. I cannot graph this graph from left to right without lifting my pencil, so it is not continuous. So let's hope that I got it right. So I'm going to go ahead and do this one as well because I am cutting the parabola 2 times. So I'm going to make sure that I show you one of these. So I'm going to grab the parabola tool. It's of the form x squared plus something. Well, in this case, negative x squared plus something. So again, my x value of my vertex will be at 0. Negative 0 squared plus 10 will be 10. It's a negative x squared, so it will open down. And if I plug 1 in, I get negative 1 plus 10 is 9, so I get the point 1, 9. Like I said, I'm going to have to cut this twice. So I'm going to grab the scissors. If I plug negative 4 into this, negative 4 squared is 16. Then I have the opposite of 16. And so I add 10 to negative 16, and I get negative 6. So I have the point negative 4, negative 6. And I can do that again. I'm going to plug in 4 this time. I'm still going to get negative 6. If my point is not on my graph, it will tell me that, so I can decide where I made my mistake. I'm keeping the middle part, so I'm going to erase the ends. I will go ahead and put a closed point at negative 4, solid point. And I'll use an open dot or a hollow dot at 4. Then I can move on to my ray. It's a half of that straight line. If I plug 4 in, 6 minus 12 is negative 6. So I'm going to start my ray at 4, negative 6. I'm going to plug in 5 because 5 is bigger than 4. 6 minus 15 is negative 9. Negative 9 is there. 5 is there. And I have a closed point or a solid point there, so I'm going to plug that in with a solid point. In this case, I can graph it from left to right without lifting my pencil, and so yes, it is continuous. And so hopefully that is helpful to you.